we'll be talking about the sort of maturation of REST API development on Drupal. And what this talk will be is a more abstract presentation of REST in general. How many folks here know what REST stands for? Okay, who's actually implemented a REST server? People that have? Cool, me too. I look forward to doing it better and easier. I've done a couple of Drupal Commerce projects where we've had to create custom REST APIs that were then used as sort of like transaction servers or the sort of system of record for a commerce mobile app, that kind of stuff. Oh, and personal introduction, I'm Ryan Zarama from Commerce Guys, maintainer and lead developer of Drupal Commerce, formerly UberCart, and then before that I was an OS Commerce contributor. If anybody ever used OS Commerce, it's not really a badge of honor. By way of introduction, I already kind of did that, I guess. Let's see how this is going to work. I'm using Reveal.js for my slides, because normally I just really suck at slides, and somebody did this for me. They made it look a little bit better, but it's proved to be kind of difficult to use. How about that? This is me and my family. I live in Greenville, South Carolina. Wife, 2 children, William and Eowyn. My wife's Christina there, and I've been doing Drupal from home since about 2009, I think. And so Drupal's been a big part of my children's life, my family's life, and I love coming to Drupal events, Drupal cons, Drupal camps, and trainings, and all that stuff, because I've got a lot out of it. I've been able to get a lot, or give a lot back in turn. And usually I go to these events to talk about e-commerce, because that's what I've been primarily doing since 2005, 2006. But this talk is sort of outside of the norm for me because it has little to do with my actual Drupal commerce work. And so the question that I try to answer at the beginning of this talk is, why am I talking about REST and Hypermedia instead of sticking with what I know? And of course, on the one hand, like everybody here is continually learning. I hope that there's new content in here for everybody that's here, that you're learning something new. At the very least, maybe you learn not to let somebody else walk off with your power adapter and dongle whenever you have a presentation coming up. But maybe you'll even learn something about the topic at hand. So for my personality, I do kind of wonder if I'm not just attracted to constrained systems. Is anybody here a QBasic developer? Yeah? Anybody remember QBasic? It was on your Windows 3.11 disks. And your Windows 95 CD, and you can probably find it in Windows XP as well, but this was my only programming language until about 2001, which was probably about 20 years after it stopped being useful. But I am kind of attracted to the idea that if I have a set of constraints that I know about and that everybody else developing stuff knows about, you can sort of apply your creativity and ingenuity to solving problems within those constraints. That it's kind of fun. I like that limitation. But that's neither here nor there. It doesn't have a whole lot to do with the topic, except that REST itself is by definition a set of constraints that we're all sort of working within when we build our APIs or even just run a web server. Another thing about me is that I'm also attracted to niche development communities. So does anybody remember the game Rogue from maybe like 1981? Well, so this game, like, it inspired a whole genre of computer games called roguelikes. If you play any games at all in the last 10 years, maybe you've heard of like Diablo or these hack and slash games that are all like procedurally generated using computer algorithms to create entire game worlds and scenarios and monsters and whatever else. Like it's a really niche thing. Like your blank stares tell me how niche it is. I also still contribute to mud development. Anybody?
You need to move.
Yeah. So the whole point behind this, of course, is that REST API development and Hypermedia API development itself is, in a sense, a niche community. Now, on the one hand, everybody's doing it, but on the other hand, most of us are doing it wrong. And so the niche part are the guys that are actually like they know that this all was born out of this guy Roy Fielding's dissertation, and you may have actually read part of it. And then you may actually be passionate about building APIs that conform to the standards and then also bring Hypermedia to the table. Does anybody know what Hypermedia is? Is that a term familiar? Okay, great, I get to teach you something. I'm not going to teach you yet, but I'll get to that. So it is a bit of a niche, but it's also it also is a mainstream thing. Like we all know what RESTful web services are. We've all interacted with REST APIs before, and I should have some slides that actually sort of demonstrate the way that we typically interact with them. But what I want to say is what I'm about to describe as Hypermedia APIs, or when I say REST, I'm actually thinking of what I call the API equivalent of a wiki walk. Have we all taken wiki walks? tvtropes.org, the best place to get lost, just clicking link after link after link, 'cause there's so much to know and so much to learn. What you can do with a fully mature REST API or a Hypermedia API is basically have this sort of traversable API, so that you can actually engage with the server from the client in such a way that the server can give me instructions on where to go next, what to do next, how to interact with that server in much the same way that we click on links and submit forms to interact with wikis and get lost in the internet. So let's talk about what actually makes the wiki walk possible, which is the World Wide Web, of course. The World Wide Web is made up of three fundamental technologies that I'm pulling from this guy's talk here. All of the source for this slide is up on GitHub under github.com/arzarama toward HyperDrupal. So all the links and my bibliography and stuff are in there if you're curious for further reading. The three technologies that he sort of lays out as the foundations of the web are, of course, the URI, what we might also call a URL, or that bit that you always say http://www.whatever.com. Yeah. So that whole thing. So there's the URI. There's HTTP, which is the Hypertext Transfer Protocol. In other words, it's the thing that your web browser uses to try to get some information from that location that you define with your URL. And then HTML, which of course is how your browser knows how to render anything. And then initiate follow-on HTTP requests when you click a link to get a new page, or submit a form to post some data to the server. These are HTTP requests driven by the HTML that you've received from the server. So URIs, of course, are simple, straightforward. They include the protocol, the domain, the TLD, etc., the host, the path, the fragment, the query string. Every web browser knows how to work with this. Most developers know how to work with URIs, know how to add username and password to them if you're doing simple HTTP authentication. You know how to specify a different port number if you're interacting with a remote MySQL database and have a specific port that you're trying to interact with. Like, we all know this. This is a standard technology that's ubiquitous. Great. The next one was the HTTP request, which is more complex. Its use is standardized, at least from like the browser web server standpoint. We know that an HTTP request has a request type. I don't know if you can read that. This is a GET request, which is fetching information from the server. Other examples, of course, would be POST requests to post data, delete requests, update requests would actually be puts or patches. There are also options in head, and maybe one or two that I'm forgetting. There are different types of requests. All right, they have a URI that they're interacting with. Then you also have something that's the other header information, like what kind of response do you expect to get from the server. So I can send an HTTP request to a web server and say, I accept as a response text/HTML, and then hopefully get a web page back and not a GIF. Or maybe if you're interacting with Drupal 8, you can have an entity ID, an entity URI that you say, get me the HTML if I'm using my web browser here, but maybe my mobile app can do a GET request to that same URI and say, I actually accept JSON plus HAL, application/HAL plus JSON actually. So you can determine what type of information, or at least tell the server what type of information you're expecting in response. And a server properly implemented knows how to deal with all that header information. Anybody want to just shout out some other header properties? Caching, expires, header, yeah. Yep. And so this again is standard. It's consistent. Every web browser is doing this more or less the same way. Web servers know how to deal with this information, and now Drupal 8 itself actually knows what to do with this information too, thanks to the Symphony HTTP kernel that we have now at the heart of Drupal 8. All right, in Drupal 7, it's much less simple, or much less intelligent, much more simple, meaning it's harder to work with. Then finally, whenever we get a web page from a web server, we get back HTML, which the response is actually going to tell us what did it return, what's the character set, that kind of information. Maybe it tells us when it expires. So if we want to cache this HTML client side, your web browser doesn't have to refetch the HTML every time you visit that URL because it's cached for as long as the server said it was safe to cache. But then really the body is what I'm interested in. You have this HTML here that I just have a paragraph and then an anchor tag here with a link out to some other page. So these are actually controls that my browser knows how to sort of translate into user interface components that I, as the user, the human, can interact with to drive this website around. I can go from the front page of Google to my Gmail inbox, and then I can filter it by messages sent to me by someone, and then click on a link to go read that email. I am driving this web application as a human, thanks to this common language that my web browser understands that the server is emitting. Like it's all very standard and again ubiquitous, so that you can get lost on the internet. You can start out at that QBasic page because I piqued your interest, and then you can find out that it's a structured programming language. So you end up clicking on a link and driving the application to the structured programming page, again to programming paradigms, and finally you end up in the footer of this page and you find an external link. And whenever you click on that, lo and behold, this other website also knows how to interpret HTTP requests and respond with HTML so that you can then continue to navigate from there to anywhere else on the website. Great, so this shouldn't be new to most of you, I'm imagining. We're all in the web industry. We know kind of how the internet works. But what's so wonderful about the internet is that whenever I went from Wikipedia to this dude's site, I didn't have to like recompile my browser in order to be able to display this guy's site. The HTML worked, it was standard, and my client knew how to understand this. In other words, we had this sort of like abstract language called HTML that knows how to communicate information from any web server to any client, a web browser, and these things are not tightly coupled at all. It's totally loosely coupled, and anyone in the world now can go and use the internet in the same way. Okay, where we're going toward with this context information, of course, is that this same kind of thing can actually drive your REST APIs, your interaction between REST clients and REST servers, and the kinds of sites that you're going to build once you get to Drupal 8 and need to start talking between websites. Okay, so what's happened here, of course, is that the World Wide Web has virtualized and democratized the library of human knowledge, and it's made it accessible in this global distributed network. Great, it's so amazing and so fun to think about. But it didn't stop there. We're also virtualizing offices. So this is actually a deck that we use, or a slide we use internally to sort of summarize the Commerce Guys ERP because we're too cheap to pay for like a legit ERP. So we string together a bunch of different web services that do their own individual jobs specifically. What's great about them, of course, is that they all have REST APIs or some sort of API that let us talk between them. They have shared authentication protocols like OAuth 2 and other things like that, so that we can take all these different web services that are on the internet somewhere and tie them together to create one coherent system for our business. Fantastic. The World Wide Web is also, of course, doing this for governments, government data. You have all of these REST APIs available to you through data.gov, so you can create these mashups of government data. You can do research, data mining, yada, yada, yada. And then, of course, if you were in my presentation earlier or familiar with where I'm trying to take Drupal Commerce, we're doing the same thing for stores. So where I see Drupal sitting is sort of like right there in the middle between how it's being displayed and rendered in browsers, on mobile devices, point-of-sale systems, whatever, and then all the back-end systems. You can sort of communicate from the back end of the stack to the front end, so that whether someone finds you through their home PC and their web browser, or is out and about on their mobile device, or comes into your store where they interact with you on your point-of-sale kiosk, that information can come into your web server through a REST API or just through a web server, the World Wide Web, and then it can go out to wherever you're doing your analytics, your fulfillment, and everything else that actually drives your business. So everything has an API. Anything can become a service. And so what is it that we're actually using to communicate between all these different things? The answer, of course, is HTTP-based APIs. So we're using the Hypertext Transfer Protocol not just to build websites and consume websites in a web browser. We're actually using that same protocol to talk between systems, to talk between devices. And so what are the different ways that we have done this historically? What are the ways that we're doing it now? That's what I'm going to sort of talk through here. So when we think about HTTP-based APIs, I'm kind of interested in how is the API that I've designed and developed, how is it making the best use of the underlying protocol? Because of course I'm a developer, I'm a geek, I'm interested in how to work within the constraints, how to design something that's as efficient as can be within the constraints of our transfer mechanism, our transport protocol. The very first thing that people have been doing, of course, for a long time is XMLRPC and SOAP. So these types of APIs are using HTTP purely as a transport mechanism. The fact that you're using HTTP to maybe send data to a server or request information from a server in this kind of API is almost like a detail, a side effect, I guess, of the fact that I'm on the internet. But the SOAP protocol in its own does not really make use of the things about HTTP that we talked about earlier, the different request types, the HTTP methods, or any other header information, or respond with anything other than XML as a response. So it's kind of just a really dumb use of HTTP, and in that regard, it's not optimized for HTTP. It's if it were, sort of trying to use the protocol to drive the design of the type of API, you could actually be more optimal. You can actually have loosely coupled clients and servers, yada yada. The problem here,
it requires a lot of discipline between the client developer and the server developer.
Exactly.
To agree upon that.
Exactly, yeah, because everything has to be documented.
Yeah.
Now, obviously with SOAP you can have some kind of WSDL document that kind of gets you most of the way there, but with XMLRPC, not so much. But yeah, it's very tightly coupled, and you have to have all of this documentation, which means you as a developer, of course, have to be providing documentation, which we're all horrible at. Yeah, exactly. But then also, if the server changes something about itself, well, how do you know as a client something changed? You don't. You're just kind of hosed. And I have a video here that you can't see. Wow, is it actually working? Well, I'm not going to play it because the internet was sucking for me. This is a video from the beginning of, is it Toy Story with the old man playing chess against himself? Is it that one? But the idea behind the video is really just to demonstrate the problem with these sort of simple, very simplistic APIs that just use HTTP as a transport mechanism. The idea is that both the client and the server more or less have to know everything about each other, and then how to translate instructions and drive the application state. Like you have to know a lot more implementing this API than you may otherwise want to. So if you wanted to play chess remotely, maybe you can find someone that has a chessboard and they can sit there on the phone and you can say, I'm moving my king's pawn 2 to king's pawn 4, and then wait for them to send the instructions back to you. Or you used to be able to play it by mail as well, which sounds awful. But the problem here is that you have to understand this thing, just like you have to understand the SOAP protocol and how the application works if you're going to write an API around that. And what we're trying to get to with the web are these loosely coupled, systems, services, websites, etc., so that you can bounce from one to the next just by following instructions in the response without having to know the special language and special format and all that. And so in order to get away from this tight coupling, people started to try to use HTTP a little bit more. So you have what's called RPC URI tunneling as your sort of next level of HTTP-based APIs. So RPC stands for Remote Procedure Call. So I, as a client, am telling a server to do something. So I'm doing it remotely, and I'm calling a procedure on the server. And in this case, these would be like URI-driven APIs. And so these are probably pretty familiar to you. If you had an API that said if you send a post request to this URL, it will delete a user. If you send a post request to this URL, it will update a user. If you send a post request to this URL, it will add a new client record, whatever else. That kind of an API is probably pretty familiar to you. And typically these are just using gets and posts, and then they're specifying exactly what URIs you should be using whenever you're writing your client application. And what's the problem with that? What if I change a URL at the server side? Well, the only way that you're going to know about it is whenever your application breaks and you come find my documentation and say, oh, between version 1.1 and 1.2 this changed. I need to update my URL. And really, like, they are using URIs, at least, so that they're using part of what makes the web special. Because you're saying that if I send information to this URI, it does one thing, this URI does another, this does another, and so on and so forth. It can change the way that you're developing a little bit, but these are still idiosyncratic. You still have to know the URIs. You still have to program specifically for that particular server. And so, like, if either end changes something, they break. So it's a bit more brittle. And it kind of develops what we'll call an idiosyncratic interface. Is the term uniform interface familiar to anyone? Kind of, yeah.
Yes.
So
delete, for example, the delete doesn't follow the post velocity.
Exactly, yeah. So like HTTP provides this uniform interface, a way to talk with HTTP servers and clients, and it specifies that your request method means something. So you have get, post, put, patch, delete, again, all these different things that you can do for different types of HTTP requests, and you shouldn't be posting to delete, you should be deleting to delete. You actually shouldn't be posting to update either, you should be putting or patching to update. So what's happened here is they basically just sort of said, instead of using the HTTP sort of verbs, we're just going to put those verbs in the URL and not really worry about the HTTP protocol. That's why this really just lights up the URI button here. You know, at least it's getting toward using the technologies that make the web so great, but it's really not that great. So as a starting point, what I would recommend to you if you're developing a RESTful web service, as a starting point, I would use what this guy calls HTTP-based type 1 APIs, or type 2 even better. So the deal here is that these APIs are using URIs to identify resources at the server, whether it's /user/1 for user 1's record, or maybe it's /products for a collection of all of the products on the site or something. It's using URIs intelligently, but then it's also respecting the HTTP request method. So that uniform interface that the HTTP, oh no, I said the, and then that becomes redundant when I say the HTTP protocol, but whatever. That HTTP says you should be using to interact with remote resources. So HTTP says you have all this information over here, these different types of data and containers of information. You should be interacting with them using these HTTP verbs, and it's a very limited set intentionally because you can optimize for these if you're respecting them, and they do kind of get all the different things you need to do, the typical CRUD range of functionality. Once you start to respect that, with your put request to update user 1, your delete request to delete user 1, your post to create a new user. Once you start here with a sort of server application that understands these things, you can kind of build from there toward a Hypermedia API.
You talked about constraints earlier.
Mm-hmm.
Those are your constraints. You're
exactly.
trying to build flexibility with just staying in those constraints.
Mm-hmm. Exactly.
Right.
Yeah.
What is the last thing I mean, except application L plus JSON?
Yeah. So what you're picking up on is the difference between, and again, the presentation that I'm sort of getting this summary from is in the slide deck, and you can read the whole thing. It's pretty cool. But so in his delineation, he's sort of determining two different types of HTTP-based APIs. Type 1 uses a generic media type to send the API response to your client. Type 2 actually uses a self-descriptive message that says in the header here, the response header, what type of data it's sending back. Okay, so typically when you get a web page from a web server, it's telling you in the response that it is sending you HTML. And maybe you can request some information in XML versus JSON or something like that. The server should respect that. Your responses should also be respecting media types. So a media type is basically the format or so of the document of the response. It may be HTML, it might be XML, it might be JSON, it might be SOAP, it might be, exactly, it could be a PDF, it could be a GIF, it could be anything. CSS, a style sheet. These are all different types of media that you can request. And this one is requesting specific media type, HAL JSON. I'm going to get to what that is in a minute. That one specifically. But that's the difference here. So what you have here are web services or APIs that you're building that define a unique resource indicator for every resource on the site, and then conform to the HTTP constraints for how you should be manipulating resources remotely. Okay? So basically what this is trying to do is it's sort of funneling people to start writing servers and clients in the same way. So that if I know the HTTP, gosh, I did it again. If I know the HTTP protocol, because I want to be redundant, then I should be able to use that interface to interact with resources on your server, my server, your server, from one client that doesn't have to be coded specifically for each different server, which is what you get if you put those verbs in the URLs instead. You don't have a client that can work on any server except the very one that it was programmed to work for. So you can see that we're conforming to these constraints, but it's creating a more loosely coupled client-server relationship such that you don't end up having to write the same, rewrite your application every time you want to integrate a new web service. You can take advantage of libraries and abstract patterns and things like that are implementing this for you, whether it's in Drupal or in Node.js or in Ruby on Rails or whatever. So yeah, are there any questions about this type of API before I move on to a full Hypermedia API?
What are some of the security implications?
Security implications of, it's actually interesting. Your like authentication and access control is really a tangential detail. So there are ways to authenticate users to your server and then determine what they have access to manipulate. But from a specification standpoint, REST itself isn't really concerned with that. So you at the application level will take care of that on your server. Obviously, yeah. And within Drupal, and I'll get to this, there are modules within Drupal that make it possible to do access control and to define your resources with URIs and to define which HTTP methods are going to work on which different resource. So Drupal does provide good tools for getting you mostly this far. Now the services module, of course, is what I'm talking about, does kind of break the interface a little bit, but it's good enough if you're doing that and not putting verbs in URLs, because you can build on this, but if you were stuck kind of here creating unique URLs for everything and just using post, you can't really grow from there without breaking everyone that's already integrated with your system. So I'm looking for progressive enhancements. If you start out here, even if you aren't using a self-descriptive media type, even if you aren't using a hypermedia type, you can change this in the future without breaking existing integrations. So additive. The last thing that you can add, of course, is hypermedia. And so I've said this word a couple of times. I didn't see any hands go up, maybe one when I said, has anyone heard this term before? It was really confusing to me because I was trying to learn this from books that kind of assumed everyone knew what hypermedia was. And then I sat down with somebody in a coffee shop in Greenville, and he's like, so hypermedia is like HTML. It's a media type, any media type, whether it's HTML or CSS or vector graphics, SVGs, that have the ability to link between other resources, to embed resources, to give you controls that you can use to drive application state, such as form elements or links or that kind of thing. So a Hypermedia API response, whether it's HTML or some custom XML-based media type or a JSON-based media type, is going to give you the information that you need to make follow-on API requests. So as an example, I might start at the front page, the home page of this API, and I would say, hey, get me a list of all the products. So I'd send a GET request to /products. And maybe in that response, I'd see like the first 10, and it would tell me in that response, if you want to see the next 10, do a GET to this URI. Or maybe it would say, if you want to filter by category, then use this query parameter. that kind of thing can happen in your API response. Typically, we're just serving up just dumb JSON. I think that's probably the standard for people that are using services or writing REST APIs. Is just straight up JSON, and you just kind of have to know what's in that JSON document that's returned, or maybe it's XML, and you just kind of have to know what's in there. But with Hypermedia, you actually have the ability to embed the data with information about the data, and then even more metadata that sort of says how to use the information about the data. Like it's all of that metadata that comes along with the actual data itself for you to drive the application state remotely with follow-on API requests. I need some help here. Like, who's not getting this? What don't you get? Let's work toward clarification. Or maybe it was just a lot easier for you guys to get than it was for me. Yeah.
So the Hypermedia makes sense if I read it. As a human being, it makes sense that, okay, there's a maze and there's a collection of mazes and this would be a list. Instead of one linked maze, there will be a bunch of them, right? So as a human, it makes perfect sense to me. But I don't think that's the purpose of it. The purpose is for the machine to understand.
Correct, yeah.
Right? So how will the machine understand? Because the machine is seeing it for the first time and it has not been programmed.
Well, so the question was, this makes sense from a human standpoint. He can read this and see that my maze has a link to grab the maze grid or something like that, or to create a new maze or something. That's this particular example. But a machine is consuming this for the first time. So how does the machine know what to do with this? And so then I'll turn it around to you. How does your web browser know what to do with an HTML document?
It doesn't. I click on the link.
But it does know. It does know some things, right? It knows how to render it. Yeah. Yeah. And yeah, it doesn't. The web browsers don't typically drive themselves. They can. You've heard of. Does BHAT do user testing in the web browser? Is that right? It can. But yeah. So the deal is, it's using a media type HTML that it knows how to interpret. So it knows what to render as a link where. It knows where to go grab the style sheet and then how to update the display of the page based on all of the different styles that you have in there. And so you can do the same thing with your API. You can use a media type that tells the client what to do with the data. So this does depend on your client knowing the media type that you're serving. But there are standard media types out there that provide sort of patterns or specifications, if you will, for linking between resources. And for example, this one's actually a really specific media type called like I can't remember what he calls it. Maybe he just calls it like maze plus XML or something like that. But in this media type specification, he actually says that if you have my mic is kind of, yeah, I'm constrained to my podium. It specifies in the media type that if you have a rel link of type maze, that you can send a GET request to that URL, to that href, and get back a maze of the size that you're specifying there. So then if you have a client that's programmed to understand this media type, then regardless of who's serving up this information, your client would know how to use this API to display a maze and then let you as the user actually click around and navigate through the maze. So questions, that's spawning questions, good.
I was going to say that what this gives you by putting the URL in the data, like the maze 5x5, you can have any kind of maze that you could come up with, and so your application can keep moving on. But as long as they know, just go get the next link, the next maze, then you can keep changing your data without changing the interface.
Yeah. So maybe right now this is a Drupal module because I just wanted to prototype it. But then when I want my maze server to scale, maybe I hand code it in some other language entirely. I switch to Node. But as long as my output, regardless if it's coming from a MySQL database, whatever, as long as it's in this media type and it conforms to the specification, it's going to be the same. You don't have to change your client at all. Furthermore, like if I change my URLs, so for example, if I suddenly don't make the 5x5 maze available anymore, I just have a 4x4 and a 6x6, well, your client wouldn't break whenever you wanted to go play a 5x5 maze. the client would actually know, oh, the 5x5 link's not there anymore. It would just render the 4x4 link and 6x6 link, and you can only click on an available link. So it's actually, the media type is defining, or it's not just returning a representation of the data, it's actually defining how you can interact with that data and how this data relates to other data, so on and so forth. Or, how to get back to the root level of the API. So again, I said that the promise of REST is the API equivalent of a wiki walk. You can have a client that knows nothing about your Maze server, but if we both are using this media type, my client can be pointed at your server's URL, and I can still use it just the same as I would anything else, just like I can get lost on wikipedia.com and click around between web pages and not have this wall if I want to browse out to some external website or something. Like, it's all uniform. And I didn't actually explain the term REST earlier, sorry. It stands for Representational State Transfer. The idea being that you have data in your server, and you want to return a representation of this data to the client that's requesting the information. Your resources don't necessarily have to map to, and probably shouldn't map to, your database tables. So for example, with Drupal Commerce, maybe we aren't all familiar with the architecture, but the idea in Drupal Commerce is that I have 5 different entity types that are all related to one another. And an order, if you wanted to get the full representation of the order, actually involves the order entity, its customer profile entities, and its line item entities, and maybe even the products that those line items reference. So if I wanted to get a full representation of my order, if I was mapping this to my database tables, you'd essentially have to make 5 different API requests in order to get all the information you need to render that order. However, as the API designer, I can say that what's really important for consumers of my API is to get all of this data together as one resource. Well, then I can expose my order resource with all of this other information included, even though it doesn't correspond one-to-one to what's in my database or how what's in the back end of my Drupal system. So you're dealing with representational state transfer, and you're not. There's more to it, but we don't need to go into all of it. But the idea is that you don't actually you aren't sharing state between the client and the server. I'm trying to think of a simpler way to put it.
The is the state has to be stored somewhere. It has to be stored on the server. So, but what REST does, that state is transferred back and forth between the client.
I think the idea that I was kind of drilling toward is the idea that regardless of how you have interacted with the API already, if I get information from a URI, it's going to be the same. So what you can do with the API doesn't change based on how you're interacting with it. Like it's supposed to be that just a communication of application state, not linking the client to the server. So like a classic example in Drupal world is that if you're using the services module, you're probably logging in as your authentication. So you actually submit a post request to like /user/login, and then from then on out you have this shared cookie that's then determining what you have access to do on the Drupal side through the REST API. That actually kind of breaks REST because it's depending on this shared information in order to generate and return these API responses or whatever. Anyways, that's kind of getting beside the point, I think. We'll move on. I wish that the internet worked when I was loading my slides here, because there's kind of a summary slide here, or a summary image. The graphic is in the source if you want to check it out later. There's something called the Richardson Maturity Model, which is just another way of describing what I've just described, how you can sort of have a more abstract API that's loosely coupled between clients and servers and yada yada. So again, at the very base, you had XMLRPC and SOAP, which is very tightly coupled, very opaque. There's no way for the web server to optimize for a SOAP request. Whereas, in a REST API request, I can actually use cache headers, for example, because the server knows how to deal with the data and all that kind of stuff. Then you had the next level, which was RPC URI tunneling, where you're using specific URLs to do specific things on the server. Don't start there. Start at using a resource URI like user/1 or a collection resource like /products or something, and then use the HTTP protocol to actually supply the verbs for how you're interacting with that remote data, whether I'm getting it, updating it, creating it, deleting it, etc. So this model sort of lists all those steps out as well, and then it actually has like this halo at the very top called the glory of REST when you start using a hypermedia media type to communicate between the client and the server. I'm not sure that this is adequately communicated all the strengths of hypermedia and REST, and so all I can really do is sort of refer you to better resources. Maybe books written by guys that have been doing this for much longer than I have, that kind of breaks down the advantages of designing web services in this way. So if you go to hyperdrupal.org, it's actually just going to take you to a blog post that I wrote last year that has a bunch of these links. Or if you go to the repo for this presentation, github.com/arzarama toward HyperDrupal, you can find, again, a bibliography of a whole bunch of books and resources that really explain the benefits of this from a client-server development standpoint. Great. So let's talk about how people have been building REST APIs on Drupal. So with Drupal 7 and earlier, people are using the services module to sort of create a combination of RPC URI tunneling and HTTP-based APIs. What I mean by that is, like I just said, people would typically use post to user login to create a shared session between the client and the server for communicating with your Drupal-based REST server. And that's an example of RPC URI tunneling. You're telling the client that it needs to take a specific action at a specific URL, and if this ever changes, well, then every client that's interacting with your server is broken. And there may be reasons for you to want to change this from one API version to the next. You never know. Can anybody imagine a way using the HTTP vocabulary to actually initiate a new session, if that's what you really wanted to do? Instead of doing a post-user login, how else might I model this using one of those 5 verbs? You know, get, post, update, delete, put, patch, something. Options isn't a verb. That's interesting. You kind of have to think a little bit like, what's the word if you obliquely? So whenever I'm posting to user login to create a new connection to my server, really what I'm basically doing is saying, you know, I'm creating a new session token. I'm creating something, yes. And so instead of posting to /user/login, maybe I have a sessions resource that I could post to, and then the response would be my session information. Instead of this just like specific URL. What was a better example from our commerce integration work? Well, another example from the services module is what services calls targeted actions. Is that familiar to anyone? Has anybody implemented a targeted action with a services module in Drupal? You have? Yeah, can you think of any off the top of your head? I'm drawing blanks here.
So the targeted action would be doing a post to a node, like if you're making a comment on a node.
Yeah.
You could do like node/1/comment.
Yeah, that's right. Yeah, so what the services module let you do is basically you have like the base resource, maybe it's node/1, which represents node 1, and then you can have like an additional, you know, parameter on the URL called /comment, where if I sent a post to that, I could basically post a comment to node 1. And the idea is, like, I think they more or less did this for convenience sake, but it's, again, breaking the constraints of REST APIs because it's requiring you to program to a specific URL. And this isn't really like a legitimate resource. It's just like a shortcut. Another way to do that would actually be to post to /comments, and in your body you sort of say node 1 is the comment, you know, the node that this references. So it's not laziness. It's more like it's something done out of convenience sake to have these sort of targeted actions or non-standard URIs and interactions with them. But the convenience, you know, it's breaking the constraints of REST, which means it's also mitigating the benefits of REST. And specifically, those are going to come around, again, loosely coupled clients and servers, media types that can actually let you drive applications from your client, caching, optimization, or performance, you know, optimizations, all that kind of stuff. So Drupal 7 and earlier let you build these with the services module. You could create good resources, good clean resources, and interact with them with the appropriate verbs. But you could also create, you know, really bad URLs. You could go either way. It's just a tool. But Drupal 8 is actually going to be much, much better because Drupal 8 ships with a REST module in core that's going to let you turn any entity type on your Drupal site into a REST resource so that if you send an HTTP request to its URL requesting JSON back, if you have access to get the JSON representation of this node data, you can. It will serve it up for you. Because we're using Symphony, which knows how to respect HTTP headers and route different incoming HTTP requests based on the request type and the media type and all that kind of stuff. So it supports, as I said, entities as resources with unique URIs. It supports representations in different formats. So HTML versus JSON versus XML versus HAL plus JSON. It supports manipulation of your resources using the HTTP interface properly. So again, respecting those verbs, even to the point that for updating a node, you will use a patch and not a put, because we're doing partial updates and not total updates, which put sort of specifies. We support self-descripted messages using HAL. HAL stands for the Hypertext Application Language, and HAL is a media type that a guy named Mike Kelly developed to let you use JSON to describe data and its relation to other data, which is great for Drupal because we deal in entities and references and so if I get if I do a GET request node 1, it's going to have all these links in it that tell me where to go to get the information on my user, where I can send a request to find a list of taxonomy terms on this node. It will tell me it can tell you what URI to post to update this node, and so on and so forth. But the big thing here, the big takeaway is that all the URLs that you're interacting with are found in the response, the API response itself, so that if you are consuming this properly, if a URL ever changes, so what? Your client will adapt and route itself accordingly because it knows how to read and interpret HAL as a media type. All right, so next steps. So what needs to happen to sort of keep the REST ball moving forward and sort of see Drupal mature as a REST API server? And I guess what I don't want to communicate is that, like, if you aren't doing the full Hypermedia thing and you aren't a Restafarian, that you're not cool enough yet. I don't want to communicate that because, like, building RESTful web services and REST APIs is a bit, and this is Paul Graham's illustration, not with respect to APIs, but it's a bit like being an aspiring actor in LA or something. You might say you're an actor before you ever actually get your break. You're waiting tables at night, but one day a week you do improv, and then maybe you have a stage gig or something like that, and you're trying to break into acting. Well, you call yourself an actor. Paul Graham's illustration was an entrepreneur. Whether or not you've actually started a business, if you're sort of trying to, and you're trying to start a startup or something like that, you sort of refer to yourself as something that maybe you haven't fully realized the title yet, but you're getting there. Same thing with REST. I mean, there are steps that we need to take to mature REST on Drupal, but it's not bad to call what we have REST, and it's not bad to use the services module and all this stuff. But we can do more, and I think that if we do more, we can actually sort of become the go-to framework, web framework for building REST APIs. Right now, the two cool kids on the block are probably Ruby on Rails and Node.js for building REST APIs. What if Drupal could supplant them? Well, then suddenly all of the money that's being spent building better tools for those languages to create REST APIs could then be spent improving the Drupal tools to build REST APIs and consume them. And that's actually quite a bit of money. If you think about every single startup out there that's raising money to build some new web service, all that money is going toward improving the scaffolding tools in Ruby on Rails or the JavaScript frameworks to interact with the service. Like that money could be being spent improving Drupal itself. So let's see if we can capture some market share there. It kind of begins with just sort of educating ourselves and then educating the community on the constraints and promise of REST, which I think I'm better at talking about the constraints than I am the promise, because it's still a bit like kind of pie in the sky, dreamy. Oh, we could have loosely coupled clients and servers that can go from one server to the next, and yada yada. But it's real. Like, we've seen that it's worked out just fine for the World Wide Web, and we can imagine a day in the future when we can actually communicate between completely different REST APIs that were never even meant to work together, and yet here they could actually sort of begin to create one big giant API out of the internet through a distributed set of REST APIs. Who knows what can happen? But that's we need to sort of be convinced that it's worth pursuing, And then we can take what we have in Drupal 8 and enrich it with more hypermedia. So we have HAL responses right now that are more or less just descriptive of the data and linking resources together. But you won't find in your HAL response right now, I don't think anyways, a query template. So if I were to do a GET request to my node collection, so /node get a list of all my nodes, I don't think, I could be wrong if it's changed since the last time I looked, I apologize to the folks there that are working on it. You wouldn't necessarily get back the equivalent of a search form with sorting and filtering and all that kind of stuff. You could, if you look at my Commerce Services project, I actually have collection resources that let you filter, browse, and sort the product catalog, and even determine what sort of data the server sends back to you. So right now, if you use Commerce Services, you can actually, you get all the functionality basically of views, filtering, and sorting, and field configuration just through my resource. And we can put all the information about that in the API response so that all of our clients can start to interact with Drupal websites, actually filtering, browsing content, updating content, all this stuff, and finding things and finding forms in the API response just out of the box, which would be fantastic. We also need to document REST server and client best practices. So like I just made a recommendation to everyone. I said that if you were going to create a REST API, you should at least start by using URIs properly, so identifying your resources with unique URIs, and then using the HTTP verbs to interact with them, not putting your verbs in the URL. That's a best practice. If you conform to that, then you're already doing better than like at least half of the RESTful web services out there. This is a link to probably the best summary of best practices I've seen so far from a company called Apigee. It's A-P-I-G-E-E. And they have an ebook on their website that you get in exchange for your email address that actually walks through all of their best practices for API design and media type design and all this stuff. And they know their stuff because they're one of the largest API hosting and analytics and performance platforms in the world. So for example, every time you send an API request to PayPal, who's handling their authentication and who's handling their analytics? I think it's actually Apigee. And so like they know their stuff. They know what's good about REST, how to make REST scale, and how to design a RESTful API that isn't a pain to work with. And then last but not least, let's develop the tools that make it even easier to consume RESTful web services, to actually traverse those media types. Much like we all have web browsers that know how to interpret HTML and give us the controls to traverse those documents, we could do the same within Drupal. Right now we have the Guzzle HTTP client built into Drupal 8 itself, but it would need additional work to know how to consume, for example, a HAL JSON response with links and form controls in it. So we do need better tooling to make it easier to build and consume these web services, and I'm going to skip over this because I don't have time. But again, as I started out the presentation, I said the promise of REST is the API equivalent of a wiki walk. So getting lost on the internet because I can follow links, because my browser knows what to do with them, and every website uses them the same way, you should be able to, 10, 20 years, who knows, in the future, do the same thing between APIs without having to reprogram your client every time you want to go interact with a new API server. That'd be fantastic, and Drupal could be a part of leading the way toward that because the opportunity for Drupal 8 is to become the new de facto solution for building RESTful web services with Drupal 8, because out of the box, you're getting the REST module, you're getting content modeling, you're getting authentication through user accounts and access control and all that stuff. Drupal could be the new platform to do that. So I do have a HyperDrupal installation profile that I'm kind of building right now on Drupal.org to basically give you a RESTful web service API server out of the box. I'd love to just sort of see what it would take to develop this further and collaborate with whoever's interested. And with that, what's that? It is. Yes, it is a Drupal 8 installation profile. So with that, I'll go ahead and tie things off because I've hit my time limit, and I'll just sort of walk out the back of the room. And if anybody's interested in talking more about Hypermedia or REST APIs, I'm happy to talk.